Okay, cool. Good afternoon or good evening. Depends on which time zone you are in. It is my honor to be here. My name is Shen Li, and I work as a database analyst for a federal research organization, and I'm also one of the co-founders for the GDG Cloud Edmonton. So today we are really, really happy and welcome the 90 of you. We have 90 students to this Machine Learning Bootcamp 2021 that is organized by GDG Cloud Edmonton, by Alberta AI, and by Carrera. So motivation is a key to success. From our pre-course survey that we know and we learned that from our students, the top 3 skills that we want to learn is first, improving the programming skills. Second, mentorship from experienced data scientists. And third, gaining machine learning industrial experience. So those are the things we really want to offer during this bootcamp. Since many of you mentioned that you value the meaningful mentorship, so here is a really simple SQL question for you. So what's the overlapping between summer bootcamp and data scientist bootcamp? So yeah, the answer is people. So during this bootcamp, we wish to provide that meaningful mentorship and also the community that is a positive and also engaging community for all of you to explore your options for becoming a data scientist or finding a job in data science related positions. And we're also encouraging that you stay connected beyond this class and also, to and stay active in our communication channels such as Snacks so that we can know every one of you and have this meaningful relationship. And I think next, okay, I need to admit somebody. One thing that you mentioned a lot is about the industrial experience from our mentors. So that's what we want to offer from our strong course leaders team. So for this course, we have our head instructor, Le Yuan and Annie, who are really experienced data scientists from the industrial. We also have our course content committee, which is Rohan, Li Han, and Hassan, who is also experienced data scientist or in the data field, and is helping to coming up with this course content. And I think, as all you know, Rohan is our bootcamp organizers and who's doing a lot of work behind the scene to keep us informed and have everything organized. So we also encourage all of you to, we also encourage all of you to feel free to reach out to our course mentors, organizers, and the course content communities. And later on our phase 2, we have our, for example, Jerry, who has over like 15 years of experience in this field and in being a developer, who will be leading our part 2 projects. So stay tuned for our more and more course leaders to get into be introduced through our course. So before I pass to Le Yuan, I'd like to introduce a little bit about who we are. So I'm Shen Li, and I'm also from the GDG Cloud Edmonton. So we are an official chapter of the worldwide network, which is the Google Developers Group. Here you see a photo, which is the city of Edmonton. This is where we are based in. And we have very strong community partners, which includes the Google experts, women tech makers, GDG developer student clubs, and Google Cloud. If you're interested in finding out more about what we can offer and what kind of connections or resources we can offer to our students, feel free to go to check our website. And for GDG Cloud Edmonton, that we have more than 650 members, and we are the community that we value the community networking, and also the meaningful relationship. We also believe that teaching is the best way to learn. So that's why we're organizing the third bootcamp. And we hope that we can spend the fantastic 12 weeks together. Next, I'm gonna pass to my partner, Le Yuan, for him to introduce himself and also the course structure.
Thanks, Cindy. It's definitely a pleasure to be here. I see some familiar faces from the audience. Nice to see you all again. Like Cindy introduced, my name is Le Yuan. My English name is Liang, so which one works better for you? By day, I work at Coursera as a data scientist. I've been in this field for about like 3 years, 4 years now. I'm still learning. Like there's a lot of stuff in this field, and the learning is just like endless. By night, I'm also a founder of the organization Coursera, which our mission is to help you become a data analyst, data engineer, or data scientist. Basically help you launch a career in the data field. We're data focused, so we only support, like say, mentees who wants to get a job in this field. We provide a lot of like learning materials, and also the goal is to get you hired. Versus like there are some other associations, like they give you courses, lessons, but we are result oriented. Next page, please. All right, yeah, I just want to give you some basic statistics. On the left side, you see the average salary that our mentees get, and how long that does it take, and then how many meetings averagely before they got hired. On the right side, we try to be transparent and like honest as much as possible. So instead of like hiding lots of information from like people who are curious, we actually show like who are our mentees, like their LinkedIn pages is, so everything that you can verify. And if you want to ask for their feedback, feel free to do so. We have like because of like we are result oriented, so we cannot host like many mentees at the same time. So if you are curious, please feel free to reach out to me either from Slack or LinkedIn. I'm basically all ears if you want to start in this field. Okay, next page, please. All right, Dr. Ng, who is the president of Alberta Ai, cannot be here today, unfortunately. I will just like speak on his behalf. Yeah, exactly. That's Dr. Ng. I also worked at Alberta Ai as a volunteer before as well, so I know the organization fairly well. Alberta Ai is a non-for-profit, non-political organization, which is located in Edmonton, Alberta. The goal and the mission is to cultivate the Alberta AI ecosystem and connect the Alberta AI community to the world. If you are curious in attending some of the recent activities, such as a monthly AI international talk, mentor sessions, ongoing nonprofit courses, please go to their website and then subscribe to their newsletter to stay for further information. Okay, so just want to give a brief overview of the course structure. I'm pretty sure you're all familiar with this. So in phase one, we'll have some like fundamental like coverage on the machine learning knowledges. These topics are chosen based on our like best forecasting and understanding of what industry wants their employees to have. And on the right side, because we do not only want to give you some like theoretical stuff, we also want you to work on some like industrial project, be hands-on, understand the difference between theoretical understanding and a real project. So we found some like lovely mentors who are coming from different companies. They are very nice, and then they will be providing these projects. As you know, there will be limited capabilities. There will be limited capabilities on who can be entered the second phase. The selection criteria will be based on, like, say, how active you are in phase one, and then your final assessment, which will be sent out later in the course. And also it definitely be based on your interest as well, right? Like if you are curious about image or like curious about computer vision, those two are for you. If you're interested in NLP as I do, that project is for you. Also, I will be leading the last one, which is called the Hitchhiker's Guide to a Career in Data Field. So if you want to launch a career in this field, I will be providing some support and information. Also, I will be providing some like hands-on project as well. Last but not the least, some housekeeping stuff. On the left side, you see virtually, which will be the tool that we use to manage all the meeting information, assignments, and you will be able to see the mentors in there as well. On the right side, you know Slack. Please ask any questions if you have during the learning. We will try to be responsive as soon as possible, but if it's too late in the night, we'll get back to the other the next day. Okay, and also we'll be using some other tools like Slido and some other stuff to run the session. If you have any feedback, please let us know. Like I said, really looking forward to learning together with you, and hopefully you'll enjoy the session and have some fun.
Sounds great. I saw Lo Yuan gonna introduce Annie, but but thank you.
I will let Annie introduce himself.
Okay, sounds great. But thank you, Lo Yuan, for the really great introduction. Right now, I'm just gonna pass to our phase 1 course instructor Annie and let him to introduce himself. I'm gonna stop sharing.
Yeah, I'll share my screen.
Sounds great.
Okay, are you all able to see the screen?
We're seeing the presenter view, so we can see your notes.
Okay, thank you. Let me change that. I actually Googled that and I confirmed that you couldn't see the notes, but it failed. So I'll try it once more. Right. Microsoft betrayed me. Okay. Okay. So let me share. Okay. So hopefully now you can see the correct one. So welcome everyone to week 1. My name is Annie and I am the instructor for the first 6 weeks. So okay, maybe a little bit introduction about myself. I did my master's here at the University of Waterloo, and then I started working as a data scientist at Manulife. And I've been working for quite a while now. And then I've been teaching also for around 2 years. I've been teaching lots of people programming, Python, machine learning, and I've been preparing lots of material and mostly geared towards people who would like to start their career in data science, because I went through all that. I don't want others to go through all that pain. So that's why I started creating all those notes. And now here I am giving the 6-week lecture to you. So that's the short intro about me, and let's get started. So yeah, this week mostly is going to be about it's actually just going to be about a very basic intro to Python programming language, and also a good intro to machine learning, a very high level overview of machine learning. We have 5 weeks left. We will dive very deep into all the machine learning algorithms as well. But right now, we will just look at AI on a very high level, and then we will dive into the algorithms and much deeper concepts much later in the weeks. Okay. So this is the agenda. So we will be starting with what is machine learning and AI, and why do people keep saying ML/AI? It's the same thing, but there's a slight difference. And then we'll go over the applications, and then why Python? Why do you need Python? Why can't I do it in C++? Or even better, why can't I even do it in assembly language? You can do that, but I'll tell you why it's very difficult. And then some of the jargon behind machine learning, and the common words, or the common the most commonly used words in this entire space of the entire subject. So And then the next one is the common packages, the tools. Kingston mentioned he wanted to get new tools. So that's what we'll be discussing here. And then we'll start practicing using the Jupyter Notebook. Okay, so let's actually look at a very high level overview of what is this AI and machine learning and the whole drama is all about. So artificial intelligence has been there actually for such a long time. It's actually been there since the 1970s or something. I don't even remember when, but it only recently started picking up pace. And the main difference is AI is the entire umbrella term. AI actually means the whole thing. AI and machine learning are not different, they are the same. Artificial intelligence is the big umbrella term that surrounds the whole thing. And then machine learning is just one set of algorithms that work in one manner. So machine learning is nothing but the set of algorithms that actually learn by looking at the data. That's machine learning. There's so much more than that. There are algorithms that deal with text. There are algorithms that read images. There are algorithms that recognize voice. There are algorithms that recognize your emotion in your speech. So machine learning is just a set of algorithms that learns from your data. And then there are these other terms: data science, big data, data analytics. So these are all different. It's too broad. So data science is nothing but the interdisciplinary field that encompasses this whole thing. And there are so many terms, but you don't need to get confused with all these terms. All you need to know is just that there is something called artificial intelligence, which is the subject. Data scientist is the job. Machine learning is the algorithms. That's all you need to know. It's as simple as that. So, okay. Now, if I look at the applications of artificial intelligence, so there is something called computer vision. Now, what is computer vision? I will show an example next, but computer vision essentially deals with face recognition, object detection, or things like video quality assessment. I've worked on a paper for video quality assessment. All we are doing is we are detecting whether the given video is actually truly 4K or not. That's the kind of paper that we worked on. Or there are image blur assessment, whether there's a slight blur in your video. So object detection, it can be used in security cameras. So imagine that you have a security camera in your building, and then you have actually recorded every tenant's face in that algorithm. Some unknown person comes in, the security camera immediately focuses on their face and then recognizes that that person actually doesn't belong to this building. That's the kind of applications that you'll have for object face recognition. And similarly, object detection. That's the most, that's actually one part of what's used in self-driving cars. The car has to know what the objects are around it to actually drive, right? So that's object detection. So natural language processing. So this is what I do. So, and in natural language processing, we all deal with text. So your emails, your chats, the surveys that you fill in, companies analyze these surveys and then try to better serve you. So the chatbots that you type, companies record all these chats and then they tell you where's your problem. They try to get the topics. So let's say I have 1,000 emails and I have to go through them. It's going to take a long time if I sit through them manually and go through those emails one by one. What if I have an algorithm that will give me, okay, what are the top 10 topics covering all these 1,000 emails? That's much easier for me to read. That's what natural language processing is all about. And then time series forecasting. That's another set of it's another set of problems that deal with weather predictions or stock market trend analysis. And then the last thing is, and that's not the last, there are much more than that. I've just put the 4 ones that I felt are very popular. Fraud detection is very common. So in banking systems, obviously there is a lot of fraud, and people need to analyze those patterns behind the fraud and then detect them. So those are another set of algorithms that are also part of artificial intelligence. And there are huge teams in banks and insurance companies just dedicated to detecting fraud, because fraud only needs to happen once, and then it's just going to cost you billions of dollars. So that's you need to detect that. Even if it happens once, that's a very costly mistake. So it's not a mistake, but it's just costly for the company. So I'm just going to show you computer vision in action. So this is how computer vision algorithms are being deployed right now. So I'm just going to play this video. So if you see the algorithm is actually recognizing all these objects. It's recognizing a car, a truck, all these other different objects. So it's recognizing a light and it's recognizing a traffic signal. These are the kinds of things that one kind of self-driving cars rely on. The car needs to know what is in front of it. You as a human, you know that that's a truck and that's a car. But how does an AI algorithm actually recognize them? That's what computer vision is used for. Okay. Is there any questions on Slido? Okay. Yeah. So I'll be moving. Okay. So this is just to lighten the mood. AI is not the Terminator. You're not supposed to get the wrong idea. I mean, okay, that is AI, but we are not there yet. We are actually on the right side. We are still figuring out the code, and we are all still learning about what's machine learning. Whenever people think of AI, they think of Terminator or some other science fiction movie, but that's way, way, way far ahead in the future, and we're not there yet. Some certain companies, if you read recent news articles and been following the news around AI, certain companies did deploy some like Sophia, these are the names of these robots that certain companies have created. They've actually, Sophia is I forgot the country that invented this, but basically that's a robot that actually speaks to humans. So people are trying to do that, but essentially we are on the right side of the reality.
No, I just have to.
Is there a question? Okay. So what is now? Actually, let's get into machine learning. So maybe you all can raise your hand. Who knows what's Yoda? I just want to know if I have to explain this or. Okay, there are quite a few. Okay. So I'll explain machine learning by, if for those of you who don't know, Yoda is just a character in the movie called Star Wars. I'm going to explain machine learning by using this example. So this is an exercise that I want you to follow along with me. So try to follow along whatever I say. And you can use the chat. I'll be monitoring the chat here. Okay. So I'm going to just follow along, and this is an exercise. This is Yoda. Just try to remember the picture. This is how Yoda looks. Now that you remember the picture, this is Baby Yoda. Try to remember the picture. This is called Baby Yoda. I'm going to show it to you once more. This is Yoda. Try to remember the picture. Try to remember how it looks. And now this is Baby Yoda. Try to remember how it looks and just remember that. Now, can anyone tell me what this is? I'm not going to show you the answer, but you have to type it in the chat. Is it Yoda or Baby Yoda? Okay, that's right. And what is this? Baby Yoda. How did you know? Now can someone tell me how did you know? Anyone, you can answer the question. How did you know? Okay. Yeah, you remembered 50-50 guess, facial features. Okay. That is machine learning for you. That exactly is what is machine learning is all about. That whole thing is machine learning. So you as a human, you actually saw the face of Yoda, you saw the face of Baby Yoda, and then you didn't need to see 1,000 pictures. You just saw 2 pictures, and then you saw that there was some difference. Smaller body, bigger size, elderly look, and facial features. Those are the things that a machine learning algorithm actually takes in and then tells you whether it's a Yoda or Baby Yoda. That is machine learning for you. It takes the data, and the way you see the data is just by looking at the green thing that's wearing some cloth, some clothes over it. But for a machine, that entire image is numbers. It takes in those numbers, breaks them down, analyzes those numbers, and then sees certain trends within those numbers. Those trends are called features. Once it analyzes those trends, it just predicts the answer, either Yoda or Baby Yoda. So this is what machine learning is going to be about on a very funny yet high level. So if you have any, I hope you all understood what I'm trying to get at. So that is machine learning for you. Now let's look at the ML tech stack. So okay, someone has a question or they just raise their hand. Okay. So what is the ML tech stack? So now you need good programming skills. That's without a doubt, you do need good programming skills. Python is going to be the focus for us for today, but in general, these okay. So I mentioned before why Python. So why not write C++? You can actually write C, and in fact, I think TensorFlow or some other algorithms at the core, they're actually written in C++. They're not written in Python. Even Python is written in C or C++. So if you keep going down deeper and deeper, you will see that assembly language, ones and zeros, bits, that is the lowest level that you can get. You can even write machine learning algorithms if you're brave enough in bits, 1010, but we don't do that. Why we don't do that? Because we want to focus on solving the problem, not addressing the language. We actually want to solve, let's say you have a business problem. You're trying to solve the business problem. You get the solution first, and then you go to the language. Now, why Python is preferred? Python has so many integrations, so many libraries readily available for you to use. It just makes things very simple. It's very easy to understand, and it's easy to interpret as well. That's one reason why we use Python. There are so many other reasons as well. There is a huge community for Python, and there is also a good support for. So let's say someone releases a new algorithm, they will make sure to integrate it with Python. So now that you know Python, you'll be able to use that new software. R is also a very good language. I think you are already familiar with it, or you might have heard of it, but R programming is another good tool to have that is mainly focused on statistical analysis. So it has very beautiful visualizations, and R programming is basically it's a stats package. It's a programming language meant for statisticians, because it's even more simpler to understand, and it's very easy to get your results and perform hypothesis testing and statistical testing using R programming language. So these are the two good ones. You can always use Java and C++ to write machine learning as well, but it's up to you. And then machine learning algorithms. You just need to know certain the basic machine learning algorithms on a high level, and then the math on a high level. If you want to get into research, then you dig into the derivations, and then you actually get into the core of the equations. But if all you want is a data science job, if all you want is just to solve business problems, understanding the math on a high level is necessary, but that's enough. If you really want to get into a PhD and do a postdoc in natural language processing or something, you need to really get into the math, because that's what they expect. And then basic stats and probability concepts. Patience to read research papers, because I do like read them a lot, and you do have to read them. And why do you read them? Because lots of these new algorithms are released as research papers and textbooks. So where is the entire data science? So there's no one single textbook for data science. It's just scattered across so many textbooks and so many research papers. So these research papers have the necessary information that you need to understand the entire data science subject. Research papers and textbooks. So those are the two things that are very important. And then databases. Database and SQL is another important aspect, because all your data is going to reside in databases. It doesn't matter if it's a SQL or no SQL, but all your data is there inside something called data lake. That's like a huge repository of that holds your data. I won't get too deep into it, but that essentially we need to understand the idea behind databases and the SQL language. So for those who might not be familiar, SQL is the language that is used to fetch the data, do some analysis, and query the databases. So it's just another language that's just used to fetch the data and do some analysis on this. So data analysts will be quite well equipped with SQL. And then the last thing is understanding the idea behind web apps, cloud computing. So these things in these days, in the past few months, what I've seen is companies, they do want you to learn cloud computing concepts, AWS, Microsoft Azure. They do want you to learn them. They don't expect you to be masters, but it's good to get an overall idea of this, because companies are expecting you to know these all these concepts, and you can learn them on the job, but you will stay one step ahead of all the other applicants if you know these concepts. So this is not the entire ML tech stack, but this is a good starting step for you. So I think I've explained a lot. If there are any questions? Okay. So now, yeah, why is Python popular? As I've said, it's easy to understand. It's human-like language. It actually looks and feels like as if you're reading some text. It's an interpreted language. I won't go too deep into it. Essentially, interpreted language means that when you run Python code, you don't declare any variables. If someone has experience with Java or C++ or something, they will know that the way a C++ program is run is first it's compiled into some other machine readable language file, and then that is run. Python is not like that. Python is all on the fly. You write Python code. It's the meaning of interpreted language means you write Python code. When you run it, the variables are interpreted on the fly. It's not pre-compiled. So that's one reason why Python is slow, but still Python is one preferred language for data science. I'm being careful with my words because I don't want to be general. So if you see the chart on the right, it actually shows the trend of Python, how Python has been growing over the past few years as compared to the other languages. So the libraries are very easy to use, and it's actually very quick to pick up Python. For anyone, even from a non-computer science background, they can easily learn Python. It's very simple to pick up that language. This is just a joke on why Python is so easy. So the guy just says import anti-gravity and he just starts flying. So that's how simple Python is. You'll understand once we actually get to the notebook part of it. But essentially, dynamic typing and all those things, you can actually explore them later. But essentially, that's the difference between an interpreted language and a compiled language. So C++ is a compiled language and Python is an interpreted language. So I promise you, this is the only slide that has as many words as it can, but it is necessary to understand these concepts. So this is actually where we get into the whole the reason you're not flying is I don't think I can see you. So, but yeah, okay. So ML jargon. So let's actually try to understand some of these terms line by line. So what's a data set? Your data, the data that you get, that you work on, it can be anything. It can be images. It can be just let's say you are training your model to predict the house price given the data about a house. So what's the data about a home? The number of bedrooms, in the kitchen size, the area, whether there's a basement or not. Those are the features that describe the data set. So a data set is nothing but your entire data in an Excel file or a CSV file or anything. It could be videos, it could be audio files, anything is called a data set. So a data set is nothing but your data that you use to train your models. Features are nothing but the entities that actually describe your data. So if you remember the Yoda example, how do you describe Yoda? The eyes, the color is green, it has those long ears, it's very short. Those are the features that describe Yoda. Those are the features. To put it another way, if you take an Excel file, the columns in your Excel file are your features. So a feature is nothing but something that describes your data. So we will get, these things will actually become more concrete when we start programming, but essentially those are the features. Now, what's supervised and unsupervised learning? So, so if I'm going fast, please feel free to interrupt me and ask any questions, because I might have missed something, and questions are the way to actually keep moving, keep engaged discussion. So in machine learning, there is something called supervised learning and unsupervised learning. So supervised means, let's say you have a code and you want that code to learn something. You want that code to, okay, what you did before, Yoda versus Baby Yoda, that's called supervised learning. I actually told you, I showed you the picture and I told you that this is Yoda, this is Baby Yoda. That's supervised learning. I am supervising you. I'm actually giving you the answers and telling you and teaching you that this is Yoda and this is Baby Yoda. That's supervised learning. Unsupervised is the exact opposite. There are no answers. So you just basically you just don't have any answers. You just have the raw data. What if I would have given you the pictures without actually telling you what it is? You would have to actually figure it out on your own. I wouldn't even be telling you that that's Yoda and that's Baby Yoda. That's unsupervised learning. There are no answers. So you have your data, which is an image, but you don't have any label. You need to figure it out from the patterns within the data itself. So that's another different type of problem. There's one more thing called reinforcement learning. I won't go much into it because that's actually very, it's much more complicated, but essentially reinforcement learning is a different class of techniques that where you actually don't need anything. You just give them, you just code, you give the model the data and it will start figuring things out on its own. So I don't know how many of you have heard about this AlphaGo. It's a good documentary as well. I would urge you all to watch it on YouTube. AlphaGo is basically the AI algorithm that has been developed to actually beat Go players. So there's a game called Go. So that it's I don't have the picture here, but essentially reinforcement learning is a kind where you don't even need to feed it any data. It will actually learn through experience. You actually just give it the data and tell it what's right, what's wrong, and it'll start learning things on its own. So that's another different wing. You feel free to explore that, because I won't be touching on that. Our focus will only be on supervised and unsupervised learning for these 6 weeks. So machine learning. Now, yeah, as I said, machine learning is the set of algorithms where the code actually learns through experience by looking at the data and either looking at the answers or it doesn't have the answers. Those are the two buckets that it falls into. Now, deep learning. I'm sure those of you who are not even in data science or in data science have heard the word deep learning. It's just going wild right now. All it is just neural networks. Deep learning is just deep learning is another word to actually say, it's just a fancy word to say that, it's just a fancy word to say neural networks. So neural networks, we will learn in the 5th week about neural networks in this entire course. Essentially, that's a different kind of an algorithm that actually again takes in the data and learns from the data. So training and testing. So I've been talking a lot about training your model. So that means you actually feed in the data. You just give the data to the model, to the code. It will learn the patterns behind the data set, and then it will start giving you new answers to unseen data. That's what I mean by training and testing. So training is just, so coming back to that Yoda example, the first 4 pictures was actually training. I was training all of you to recognize Yoda and Baby Yoda. That's training. Testing is when I actually showed you the picture and I asked you the answer. That's testing. So this is a common jargon that's used in the machine learning. Training is just learning the data. Testing is predicting unknown pictures or unknown data. And then the last 3 are are generic programming jargon. So, okay, so functions, libraries, and packages. So function is nothing but a block of code that you give a name to, and then it'll whenever you want to execute that function, you just need to call that function once. Just like let's say my name is Annie. If you call my name, I'm going to stop and say, do you have any question? That's a function. So a function is nothing but a block of code that executes something whenever you keep calling it. So a library is nothing but a collection of functions that are grouped together. So a function is nothing but a single unit, and then a library is nothing but a whole collection of functions that you call upon whenever you need to run that code. A package is nothing but a collection of Python scripts. So this is some common machine learning jargon. Okay.
Anirudh,
there are
I think
few questions.
we should take some questions. Yeah.
Okay.
Do you want me to send them? Okay, fine. Yeah, you can go with it.
Are they on Slido? Because I see them on
they're
Zoom
actually in the
well.
Zoom chat. So what I'll do is I'll just say them out loud and you can answer them. So the first question is from Sunil. He asks, in this course, will you be touching on how to store the model after training and use the model in an app for prediction?
Yeah, we will be doing. I will teach you how to actually store the model after training. Using the model in an app for prediction can be done. It's not that difficult, and I will show you that as well. Yes.
Awesome. So I guess we can move on to the next one. Next one is from Shubhadeep. He asks, training data is only for supervised learning?
So everything is training data, like whatever you have, okay, there is so basically there is just data, and then you are the one who decides to split it into training, test, and validation. That comes to the next question. So you just have data, and then what I mean by training is you need to teach the algorithm what the data is all about. In case of unsupervised learning, you still have training data. It's just that there is no answer to actually look at. You find out patterns, and you cluster these, you group the data into separate buckets. So that's what unsupervised learning does. So both of them have training data. In case of unsupervised learning, you try to find out the hidden patterns, and then you group the data. So it is still called training data. And that comes to the next question: how to spread training, testing, and validation data set. So there is a general rule of thumb that you just take, okay, let's say you have 100 data points. You take 70%. I don't even know what the rule is. Like it's just up to you. Like it really depends on the data set. So you split it, like you take 70% of your data set as training, 30% as testing. You can then further split that 30% into half and half as testing and validation. But let's say your data set is too small. I need more amount of data for training, right? So then I would decide it based on the amount of data I have. Let's say I have 100 data points. I would take 50 for training, 25 for testing, 25 for validation. Let's say I have 10,000 points. I have more. So I would take maybe 80% for training, 20% for testing, because 20% out of 10,000 is a big number. So that's how you decide. And Sunil asked difference between module and package or library. These are a bit confusing. I can understand that. Module is nothing but the function. So, okay, function is a smaller unit. That's just a single block of code that you want to run whenever you call it. So I have an exact example in the notebook. And when you look at that example, you'll actually understand what a function is. So a package is nothing but a collection of Python scripts. So you write your code and you break it down into multiple Python scripts. The whole thing is called a package. A library is nothing but a collection of functions. So don't worry about the differences between this. When you actually start coding and when you get the experience, you yourself will become very clear with those concepts. But essentially, function is a smaller unit, library is the bigger one, package is the much bigger one. Okay. Yeah. Okay, fine. Now, so these are the commonly used libraries. So Pandas is one very, very, very popular tool that's used here. So Pandas is one popular tool that allows you to do data manipulations on your data set. So it allows you to get in Excel files, CSV files, and all those things, and then just do any kind of manipulations or transformations. Numpy is a scientific computing package. It allows you to do, it allows you to define arrays. I'll tell you what arrays are next. It allows you to define, perform linear algebra. It actually allows you to do that. There are lots of values built, linear algebra functions built into this Numpy package. So you can use them. Scikit-learn is like the home of all machine learning algorithms. There are so many built-in algorithms inside this package called Scikit-learn. So notice that I'm using scikit package and library interchangeably. It's fine. Essentially, Scikit-learn is called a package. It's just a collection of many different libraries. People still say Scikit-learn library or Scikit-learn package. That's okay. So, okay. So now let's actually look at what is a Pandas data frame. So imagine your Excel file. Your Excel file is nothing but a data frame. So Pandas defines these tables as data frames. So data frame is nothing but your table. And then there are certain terms that are used to describe these, the different components in the table. That's what I've marked them down. So I'll go over them one by one. So if you remember the ML jargon page, the first row that you see, passenger ID, survived, P-class, name, age, sex, part, ticket, fare, all these things, they're actually called, they are the features. So these are the things that actually describe your data. So these things are actually called features. Each column is actually called a Pandas series object. So all the columns, they are actually called features, and each individual feature in Pandas is referred to as a series object. And then one single row is called a data point. And then there are different types of data. These are strings. So a string is nothing but a group of characters combined together. Like these are names, right? Alan, Mr. William Henry. Yeah, is there a question? Okay, fine. So the string is one kind of data set. So your name is actually called a string because it's a set of characters. That's how you define a string, a set of characters. So this is a string. This is a categorical variable. So what I mean by categorical variable is, okay, in this data set, there are only two categories of gender, male and female. So it's a normal word. I'm saying category. So that's what categorical data means. It's just a limited set of words that actually describe the entire column. So in that entire column, there are just two categories, male and female. That's called a categorical data set. It's a limited set. A categorical data point is nothing but a finite set of data points. That's what a categorical data set is. You can define a certain limited set of categories. Let's say music genres, blues music, pop, rock music, pop rock. So there are a limited set of genres. So those are all called categories. So that's what a categorical data refers to. And then we have numerical data, the usual numbers. These things that you see, this is very common to notice. If you see the one that I've circled in blue, NaN, that's actually a missing value. So let's say you're a person who's you're doing a survey, and you go to each someone's home, and then you ask them, you're just doing a survey about the community. You just want to find out the people's name, their family name, and all that. Certain people are hesitant to reveal their last name. So in that case, you would just put a blank. That's a missing value. You just don't have that value. So that's how it's represented in the Pandas data frame. Okay, so moving on, Numpy is the next one. So Numpy at its core is nothing but it deals with array objects. So an array is nothing but a list of items enclosed in square brackets. An array is a data structure that actually holds a sequence of elements. It can hold numbers, it can hold characters, it can hold strings, it can hold decimals, it can hold anything. An array is nothing but a data structure that is a collection of elements. And the good thing about array is you can access the elements instantly. So that's sort of getting into the computer science part, but essentially an array is nothing but a data structure that is a group of elements that it holds together and that you can access immediately. So let's say if you look at this, I want to access the third one. So I would just use the name of the array and just say 2. I just want to get the second element. So this will all become very clear once we start doing the exercise. So essentially that's pandas and numpy arrays for you. I will get into the operations of numpy arrays in the notebook. So I think now it's good time to start practicing. Before that, let's take a short break for 10 minutes so that we can stretch ourselves. Okay, so there is a question. So can array and matrix be used interchangeably? It's a good one. So a matrix is nothing but multi-dimensional, a 2-dimensional array. So an array has n dimensions. You can define 1, 2, 3, 4, 5, 6 n dimensions, but a matrix is a 2-dimensional array. So it's actually a 2D. There are 2 arrays inside the matrix. So I will show that to you. I will show this exact thing to you in the notebook, but that's essentially that one. So an array is 2D, and then an array, a matrix is 2D. An array can be ND. Okay. Yeah, maybe the 3:53. So maybe let's meet exactly at 4 p.m. Rohan, Zoe, you can.
Yeah, sounds good. I was going to suggest that it's 4 p.m. EST, but for the mountain time it's 2 p.m. So 7 minutes we'll be back, and it's good to have a healthy break.
Yeah.
Right now there's no additional questions in the Slido. So if you have more questions, I think we've addressed most of the questions in the Zoom chat too. But if your questions haven't been addressed yet, feel free to send that into the Slido, and Vanny can just answer them from there.
Yeah, I'll be here, so you can feel free to ask me any question you want, and I'll be happy to answer that.
And great job. I think, Annie, this is the really probably the most clear concept definition have seen for machine learning. It's really unearthed, and it's easy to understand.
Thanks. Yeah, so okay, so now we are actually going to into the actual Jupyter notebook. So I'll share my screen, and you all have not seen a Jupyter notebook before. I will show you that. So let me share my screen. Okay, so you just need to go into the URL and type. I think you all have, some of you have at least experienced Google Colab before. So you just need to go here and type colab.research.google.com. Once you enter that, you will come here, and then I've already shared the notebook to you via the Google Drive. So download that notebook, come here, click file, and then just click upload notebook, and then browse into your directories, and then fetch the notebook, and then just get it here. The other thing is to download the dataset. So for those of you who might not be familiar with Kaggle, Kaggle is a website that actually hosts lots of open data sets and lots of competitions as well. So if you just go to kaggle.com, you will see that there are a bunch of, they actually changed the interface, that's what I remember, but effectively it's just a list of a huge collection. It's a big open data science community that actually has lots of data sets, lots of challenges, lots of competitions that people always try to participate in. So today we are actually going to be dealing with, today and for the next few weeks, we are going to be dealing with the dataset called Titanic Machine Learning from Disaster. So this is the data set that has been collected for surrounding the Titanic ship, based on the movie Titanic, and also based on the real incident. It just collects details about the people, the passengers on board the ship, and then the competition here is to actually predict the survival rate of the passengers. So who most likely survived out of this big disaster? That's the goal here. So it's very clear. They actually have lots of videos to actually explain what is the competition all about. They provide you the data set. They give you the data in this format. I provided all these links, so you can go ahead and download it. And then basically, they also provide you one file as a sample submission. So this is how you submit it. So the final, the way that you actually submit to the competition is in this format. We will try to do that. So at the end of this bootcamp, you all will be ready to actually make your own submission in this Kaggle competition. And this competition actually has been running forever. Like I've seen this competition since 2015, 2016. It's still there. Like it just keeps going on. It just never ends. So you all get into this website, download the data set, and then there is another good, before I forget, another good point about Kaggle is they have all these existing code that people have already written on and published their own notebooks. This is actually a very good way to start learning data science. You just need to go into code and then click any one of them. And then these are the notebooks that people have themselves done. And then you can actually learn from them. So you can see how they have actually done the analysis. And I've actually learned lots of tricks from these, reading these notebooks as well. So that's a short description about Kaggle. Now, once you come here, you see this small, okay. Now you see this small upload button here. Just go there and then get all those CSV files that you just downloaded and then just dump them inside your Google Colab. So I'll just give about 1 minute so that you all can just put a message saying yes when you're ready, and then I'll start. Just have this data on the left and then the notebook on the right, and then we are good to go. So the notebook is there in the Google Drive link. Would anybody be able to share that?
I'm on it.
Okay. So Leon will share the link to the Google Drive. Inside Google Drive, there are 6 folders, one for each week. And then the week 1 actually has the notebook and the data set itself. You don't even need to go to Kaggle. So I will give a few minutes so that everyone is set up properly. So even I will get into the Google Drive. So I have to find the link. Okay, so it's actually there here. So even in virtually, I've actually made a post. So you just, yeah, this link. So you just get into that link, and then you will see 6 folders, one for each week. And then you just click week 1. Then you see this here. You can, I think you can just right click and open with, and then you'll see it should be there. If not, you can just download it. But this is where the notebook is, and download this folder as it is. So this folder actually has all the files.
Yeah, this step is important. So please make sure that you have everything set up.
Because the entire notebook relies on that data set. Once everyone
so after downloading, do they need to upload the data to like mount the Google Drive and upload the data?
No, you just, okay, when you finish downloading the dataset and the notebook, just come here, open Colab, and then click this this small folder button over here. There's only one file. Okay, but how do I see 2? Okay, if the Google folder isn't working out, then click the Kaggle dataset. Yeah, it's in the drive. Okay, yeah, click on the Kaggle. Either download it from here, get into this link, and then just enter the to download the dataset. You need to enter the competition. So just come here and click download all. Now coming back to Leon's question, once we come here, you will see the small folder icon over here. Just click that, and then you will see a small file upload button over here. Click that file upload button, and then navigate into the Titanic folder, and then just upload them. And it should be done. That's it. You'll be able to access the files in your notebook immediately. It should just be here. Yeah, just message, put a message saying done, so that I know that at least a majority of you are at where I
am. I will put a question in Slido, so please upload there, so I know how many people actually finished it.
So try to use Slido. We are trying to. Okay, so let me share the link. So Colab is actually Google's tool to actually do collaboratory work. So Mila, you asked a question. So just type in this link in the URL, and then you will be directed into this page directly. All you need is your Gmail account, your Google account.
When I type the link, it just say welcome to collab.
Yeah, welcome to Collaboratory. Try to sign up. I mean, once you link it to your Google account, there will be an option to upload a new notebook. So you will see something like this.
So I have to sign up. Let's see.
So you just need to sign up with your, okay, maybe, okay, I'll actually do it from the start. So 1 minute. But okay, if I do it, I actually forgot my password. So, okay, wait. Okay, so basically what happens is, okay, let me actually, how do I show it? So this is what you will see if I say Google. So this is the page that you will arrive at. So it's going to show something like this. Even if this is not there, you will at least see this. This is what I think you are seeing. What is collaboratory? Welcome to Collab, right?
Yes.
Okay. Now here, make sure you are actually signed in, so that all these notebooks are actually saved in your account, and then go click this file and then just say upload notebook.
Oh, I see. Okay.
So once you click that, you should see the screen. This is just dark mode. It's a color difference. That's it. Yeah, the link to the notebook is given. Yes.
Oh, I see. Okay. So I just highlight that and copy on the link.
You just you just click file upload, and then you just point it to browse, and then just point it to wherever the notebook you have actually downloaded. So another. Okay. Okay, it's actually there inside the week. Okay, if you are not able to see the other files, I would suggest when you open the notebook, try to click this link over here, kaggle.com/c/Titanic. And then when you get into this page, it's again going to be linked to your Google account. I mean, you can sign up using Google, and then just come here, click data, and then just click download all. So you'll just get the whole thing, the entire Titanic folder. Okay. Are there any responses on slide? Okay, I will support it.
Sorry, Ani. So I went
Yeah.
to Lab, and when I click on file upload, so do I go to upload or?
Yeah, when you click upload, okay, the file upload, I see. You just click this file upload, and then you just drag these three things. So you just need to come here, click the folder, click upload, and then just select these three files that you just downloaded.
I'm able to get on this page in general.
Which one? Oh, so you just need to click this folder icon over here on the left. There's a small, there's a 3 lines, there's a magnifying glass.
So I wasn't able to open this.
Okay. I'll actually do it from the beginning. So whoever is typing, just try to follow along with me. The first thing that you need to do is type colab.research.google.com. Once you type that URL, you will come into this page. This is the first page that you'll see. Just cancel this. You'll see welcome to Collaboratory. What is Collaboratory? Now here, there are 2 things that you need to do. The first thing is click on file, then click upload notebook, browse, and then select your notebook. So my notebooks are located here. So week 1 notebooks, and then ML Bootcamp. So you just select that notebook and then open it, and then it will come as this whole page. You'll start seeing this whole thing.
I see. So I'm supposed to download the week ones to.
Yes, you're supposed to download the week 1 notebook to your desktop and then just do whatever I did.
Okay.
So all those things are there in that Google Drive in this folder. So once you've actually done the Kaggle link is there in the, okay, I'll post the Kaggle link here. So I'll also post it in Slido so that it's much easier to track. So once you've actually gone into Kaggle, you can download. So now this is the first step to actually upload the notebook. You just click upload notebook, browse, and then you just need to select the notebook here, the one that you just downloaded. If everyone's finished the notebook step, okay. The next step is to upload the files. So you see this small files, the button here that actually looks like a small folder. You just need to click that one, and then you'll see this upload, the file upload icon over here. It says no file selected. You just click that, and then again get into wherever you actually have the Titanic folder, and then select everything, and then just open it, and the whole thing will get into it. So try to get used to this every week. This is the exact same step that we will be doing always every week. You will be given a notebook. You have to get into Colab, upload the notebook, upload the data. Those are the only 2 steps that you need to do every week. Okay, let's check slide 23. Okay. Yeah, we can. We have lots of time, so. So once you get into that, this is the final page that you need to see. You need to see train, test, gender submission. Forget about the sample data. You just need to see the train and test. So Zach, whichever one works for you. Like for me, I found this to be simpler, but I also did the other way. I went into Google Drive, I right click and I just did open notebook and it actually went directly to this page. So even that is possible.
If you still have troubles like setting it up, feel free to speak up so we can unblock you.
So when I went, so I was able to open the ML Bootcamp week 1. And then when I select file, it didn't have the CSV files.
So when you, let me download it. So when you actually download it, you're going to get a zip file. I think Ruhul is talking about that. So when you actually download it, it's actually going to be a zip file. It's going to be called Titanic.zip.
Mm-hmm.
Double click that and extract everything that's inside that. So
Okay.
if I actually download it, you see this is the file that you're going to get, Titanic.zip. Save it and then right click it and extract the contents inside that file, and then you will see those 3 CSV files.
Okay.
Okay, maybe I'll just save it. Yeah, you can do that as well. Yes, you can download them. You can like download them individually here. Like there's a download button here, so you can click that file, download. Click this file, download. Click this file, download. You can do that, or you can click this one, get the zip file, and then once you get the zip file, you will see. Maybe I'll just do it. Okay, so download all, save. If I just get here, okay. So if I just come here, if I save it, now if I get into, so if I get into this, you'll see you actually have this one. So this is the file that you'll see. Just mine is Mac, so I just need to double click it. Windows, you might have to do WinRAR and right click and extract it, but just extract the files, and inside this you should see the 3 gender, test, and train. So make sure you have these 3 files, and then now the process is the same. Just come here, upload it, and then select those 3 things. So did you actually download all?
I'm trying to download all, but it asked me to register. So
Yeah, you have to just just sign in with your Google account, and then you can you already logged into Colab, so you just need to sign in with your account.
I
so
also
the 3
post the data
files
in Slack, so if you want to get from there.
So Slack has all the 3 files as well, and you just once you click this one, you actually have. So I actually saw all the 3 files. I just showed you as well. If not, okay, someone just posted the file. Like you can. Thanks for that. So you can actually download that as well. So which file do you see, Ruhul?
So I could only do individual files to download. The download all didn't get me to do
Okay,
anything.
that's fine. That's some bug with Kaggle. We can't do much about it. If you want all 3 files, then I would suggest click on train and click this download button. And then someone actually posted it on Zoom as well. You can just download that. So someone's in the waiting room.
Yeah, sorry, I just admitted.
For those 3 CSV files that I also just uploaded to our shared drive, can anyone tell me if you can see it?
So if you all are able to get into Kaggle and just click for each individual file, if you're just able to click download here, that's more than enough. So, okay, Ruhul has got it. So you just need to come here and click download on all the 3 ones. I just need to come to this page. Click the folder with the 3 dots.
Okay, sorry,
this
sorry
one.
everyone. I think we should proceed. So if you have trouble accessing the files, you can still get them afterwards. So it doesn't affect like what you'll be doing in this session. So you can still like watch any doing all the stuff for this session, and we'll help you set up everything afterwards.
Okay, I'll be starting right now. So only the last half of this notebook actually deals with the data. The first half is actually Python programming. It's actually pure Python programming and data structures and all the concepts within Python programming. So let's actually start going over this. When we get to the actual part where we deal with Pandas data frames, let's actually make sure everyone gets the files. So until then, try to forget about the files for now and try to only focus on whatever I'm saying. Yeah, Leon did upload the CSV files on the Slack channel. Okay, so so we will be starting with the Python and Python programming and common data science tools. So let's start at the very beginning. Okay, is this fine? Okay, sure. Yeah, so now I'll just zoom in one more step. Okay, so this is the way that let's start at the basics. So what's a variable? So a variable is nothing but a block of memory that holds some value. It's just a block of memory somewhere in your computer that actually holds some value. So this is an integer. So this is the name of the variable, and I'm actually assigning the value 5. This is a string. It's actually a group of characters, and then I'm assigning it some value, and the value is a string, and this is the name of the variable. So in Python, you just need to declare the name of the variable and then just say equal to and assign something to it. This is a character, and then this is the decimal value, and then this is another way of assigning variables in Python. If let's say you have 2 variables that you want to assign, just say a comma b, and then 9 is actually going to go into a. May the force with you is actually going to go into b. This is a simple way to actually. Okay. Now that you actually understand, this is the first step where you actually start with in any programming language, how to assign variables and how to create them. The next step is some common data structures. So the next step is the as I was saying, the data structures. So what's a data structure? A data structure is nothing but a way to organize your data. That's all a data structure is all about. It's a way to actually organize your data. You have these hash maps, you have those arrays, you have lists, you have stacks, you have queues. All these are different ways of organizing your data. In Python, there are few data structures. These are the most common ones. So the first thing is a list. So a list is nothing but a group of items that you actually enclose in these square brackets. So in a list, you can have items of all string, or you can have string, you can have character, you can have an integer, and you can have a float. This is how you define a list. A list is nothing but it's enclosed in these two brackets, and then you just comma separate them, and then that's a list for you. Python doesn't have a built-in array, but it's actually called it's a list. So C++ or some other programming languages have something called arrays. Python has list. So now now that you have understood list, let's get into the next one. This is called a dictionary. So a dictionary is nothing but key value pairs. So I've taken my dictionary's name is day of the week. I've assigned it. The way that you create a dictionary is by putting floor brackets or curly brackets. So notice that list actually has the square brackets, and then dictionary has the floor brackets or curly brackets. So curly braces. So once you do that, the one on the left is called the key, and the one on the right is called the value. So the key 1 has value Monday. The key 4 has value Thursday. The key 7 has value Sunday. So it's a key value pair. So this is how you define it. You have a key, and then you put a colon, and then you put the value. And then you enclose this in these brackets, and then you just name it. Name your dictionary. So that's how you actually create a dictionary. The way dictionary, now you see that what's the difference between all these data structures? It's just a different way to hold data, right? A dictionary is such an easy way to access them. Like I can just once I can just access these individual values just by specifying the numbers. I will show that to you in a moment. So let's maybe I will create one cell and start showing you. So let's try to do this first. This is a list of let's actually do this mixed list of items. You can actually code along with me. So to create a new cell, just hover your mouse over this in between these two cells and just click code, or you can even click it here. So you can just come here and click code, or you can click it here and then just type in the same. As you keep typing, Google Colab starts suggesting those. So I didn't run this. So you need to run them. So just hit the play button, and then as you keep typing, Google Colab will start suggesting those variables that you have actually just defined. So just click that and either hit the play button, or the shortcut is Shift Enter. So Shift Enter, and then you will see that same thing has actually been printed here. This is how a Jupyter notebook works. So now now let's actually see how to access them. So in Python, array lists actually start by zero indexing them. So what I mean by zero indexing is the first element in this list is has an index called 0. An index is nothing but the position. So let me show that to you. So just say mixed list of action items, open the square bracket, and then just say 0. Now do Shift Enter. You will see hello. Did you all get this? Most of you should have gotten that anyway. Okay. Okay, Maggie, try to download the notebook. I think Google is preventing you from accessing my notebook. Try to download the notebook separately.
There should also be a make a copy button in the interface.
Yeah.
So.
Yeah, it normally works well if you just make a copy, and you can move that copy to whatever folder you made for this course, and you can make changes and won't be associated with Annie's notebook anymore.
So you just, if you're stuck, just get into here. Sorry for sidetracking, but just get into this page, click the drive link, go here, and then in week 1, you will actually see the notebook. All you need to do is just download the notebook and you're good to go. Okay, so now that you all seen this, this is what I mean by zero indexing. So 0 is the first element, and then let's access other elements. So which is the other element? So this is 0, this is 1, this is 2, 3, 4. So 0, 1, 2. Let's actually access pi. So the value of pi. So I'm going to say 2, and then you're going to access everything else. Now I want to. This is the way to access individual stuff. How do I access a group of items? That's called slicing. So you use a colon here. Just put a colon in between, and then type in the numbers that you want to fetch. Let's say I want to get hello, I want to get 1, and I want to get 3.14. So what are the positions? The position of hello is 0. So put 0 on the left side. The position of 3.14 is 2. So if you count from the beginning, this is 0, this is 1, this is 2. To actually get 3.14, you need to put the next number. So you're not, if you say 2, I'm not going to get 5. You need to put 2 plus 1, which is actually 3. That's how Python list slicing works. You always put the next item to get the previous one. So what this means is it's going to start at 0. So this actually means it's going to fetch 0, 1, and 2. That's what it means to say from 0 to 3. So I hope you all got this. So yeah, make sure that you always run every line. Like you all the code below actually depends on the code above. So you have to keep running every code. So from the beginning, click each individual cell and then run that cell. Then again, click the cell and then make sure you run that cell and then proceed to the next steps always. That's how it actually runs. So I hope, Edward, I hope you got that. Okay, so now that you have this, thing, let's actually, this is list slicing. This is another thing. You put one more colon and this is the step. So what I mean by step is, let's say I am going to print everything from 0 to 5, and then in steps of 2. So I'm going to print every alternate one. That's this third one. So let me run that. Let me show you. So just say 2 here. Did you see what happened? So when I said 0 to 5, I mean 0, 1, 2, 3, 4. I mean the whole thing. And then I said step 2. Step 2 means print 0, avoid this one and go to the next one. So that's why I got hello 3.14. And then print that, avoid this one, go to the next one. So if I say step 3, that means print this one, avoid this, and then print this one. Then avoid this, and that's it. The list is done. There's no more, so that's why it stopped here. That's called step. Okay, so the way you add a cell is slowly place your cursor in between 2 cells here. You'll see something called port, or click this one over here. That's how you add a cell. Just put it slightly under the cell and you'll find it. Okay, now that's a list. I hope list is very clear to you all. Now you see that list is okay. Someone asked a question: is it possible to define the step but not define the end? Because for a large list, counting through many is cumbersome. Yes, actually that's a very good point, because if you have a very big list, I'm not going to keep counting 0, 1, 2, 3, 4. How long can I count? So I'm just going to do this. Let's actually get that one again. So mixed item, just specify the first one, the starting point, and then just leave the colon. It's going to print the whole thing. Don't specify anything here, or you just leave it. It's going to print the whole thing. List slicing is used to select a specific one. That's how you select the whole thing. So you don't know the end. Now, can actually anyone tell me how do I print it in reverse? If anyone can answer this, it's you really got the concept of list. How do I print the items in reverse? Okay, that's right. So let me show you. So it's -1. You see the whole thing is printed in reverse. So when you go to lead code, if they ask you to write it in C++, do you know how many steps you have to write to actually print the element in reverse? In Python, it's just one line. So that's how simple Python is. So okay, so that's how you print the elements in reverse. Okay, now so we have actually covered the whole thing about list. Let's actually get to dictionary. Now you see that list is useful, but what if I have key value pairs, like something like this? if I were to access something like this, I have to create a list called 1, 2, 3, 4, 5, 6, 7. And again, I have to create a list called Monday, Tuesday, Wednesday until Sunday. And I have to keep mapping those. I have to make sure that those two lists are matching. Dictionary is useful here. So say day of the week, then put whatever number you want here. Let's say I want to access today is Sunday, right? Let's try to access Sunday. So all you need to say is put the key here, and then you'll get Sunday. You can't do the reverse. You can't type Sunday and expect to get 7 because the key is unique. The value is not unique. That's the point about dictionaries. So I can actually have 8 and still Sunday. I mean, what I'm saying is, okay, wait, let me try that. Yeah, 7 Sunday, 8 Sunday. You can't do this one. You can't do this. So let's actually try what will happen. You don't know which 7 you're talking about. Like, am I talking about Sunday or am I talking about Sunday 1 to 3? It just got overwritten. So that's a very confusing thing to do. So make sure that your keys are very unique. That's a dictionary. So a dictionary is nothing but a hash map. And that's how you can describe it. So it just maps keys to values, and it's actually a very useful data structure. Then the next one is tuple. So a tuple is almost like a list. So a tuple is almost like a list. Like it is, you see that it's actually having it has the same structure, but it's just that it's there are round brackets in the end. So what's the point of having a tuple? The most distinct feature about a tuple is it's immutable. You can't change a tuple unless you actually go and change it here. Programmatically, you can't change a tuple. So you just say my tuple, then you're going to get this tuple. You can access the tuple exactly like you're accessing a list. I'm going to say 2, and I'm going to get Microsoft new update. Let's actually try to assign something else. Did you see what happened here? It's actually throwing an error. Tuple is immutable. You can't change a tuple. But I can do this for a list. You all can try it out right now. Just put put the list name here and do this. The list item will change. This will not happen for a tuple. Last one is set. A set is nothing but the mathematical concept set. So if you say my set, it's a unique set of values. So you see here, I actually have 2 2s, 2 3s, and 190, but I only have 1 here. So set is nothing but a unique list of values. So these are the most common data structures in Python. If there are no questions here, I'll move forward. So one more thing before I forget, how do you actually add new items to a list? There's a function called append. So let's actually get back our list, mixed list of items. So how do I add one more? You just say dot, and then you say append. You see, Google Colab is already suggesting this, but do not rely on the suggestions now. It's a good practice to type everything from scratch to actually be good at practicing anything, but just say dot append, and then you put whatever value you want. So I'm going to put a string of number 609. So now let's actually print you see here, the number actually got appended to the end. It's getting appended to the end. That's what's happening. Okay, why don't we actually test that thing? Our set's mutable. So it should not. So you can't even actually, you can add items to a set. So you just say add. So you can do that. So let's actually select, sorry, let's do this. So you can't, so a set is different from a list. You can't access them like this. Like you can do set operations. So if you have another set, you can actually do dot intersection. So a set of items is actually meant to do set operations. So intersection, you can do difference of sets. You can do all those operations. Whenever you want to perform, like, okay, let's say you actually came up at some data structure, you don't know what to do with it. In Jupyter notebooks, one advantage is you just click dot and you will know what to do over here. Like you will actually get all the items, like you will actually get all the functions that are possible with the data structure. So if you see here, there is an item, there is something called pop. Pop means if I say pop of 2, it's actually going to, sorry. It's actually going to give me the element. I keep clicking pop, I keep getting all the items. Like if I keep saying pop, this is how I actually access the elements. So the set is empty. So I popped the whole thing, or popped all the elements from the set. This is how you actually access the elements, and you can add elements by saying add. That's how you do it. Okay. Those are the data structures. Okay. So now another thing is the conditionals and looping. So the if statements are known as conditional statements. Yes, the element is getting deleted from the data from the set. When I said pop, everything went away. So I have to again run this cell to actually regenerate the set, and then if I say pop, the whole thing is going to come out. Each element by element. So please explore the each data structure a little bit more in detail, because I'm actually not covering everything. List actually has a few more functions. There is a function called remove. So if you want to remove some element, you can just say come here and just say type remove, and then you can remove any one of the elements you want. You can just type hello over here, and hello will go away. So there are actually many more functions. Even in dictionary, there are some functions, like let's say day of the week. You say dot keys, you are going to get all the keys. So there are actually multiple functions within this. It's good to explore them. And then there is something called dot items. So these are the most common functions that you will actually use for when you actually work with dictionaries. So dot items actually gave me a list of tuples. You see why you need to know about tuples? This is actually a tuple. You see here, there's a round bracket here. That's each item. If I select 0, sorry, I can't do that. So so if I see that I've selected the first one, that means I've actually got one Monday. So 1, Monday is one tuple that represents the first key value pair. So there are multiple different operations within a dictionary. You will get to know them as you keep practicing and coding. Yes, adding is append, yes, but you can't. Okay, so the function, adding an item to a set and appending an item to a list are the same, but you can't. Okay, you can't say my list dot add, and you can't say my set dot append. So the name of the function is just different. That's how it works.
Just a quick reminder, and because of time interest, let's move forward. And if you have questions, please
I have something for you. Come here.
Okay. So yeah. So a set is okay. So what if they've asked you to find out the unique, the number of unique values in this list? You don't need a for loop. You just say set and find out the length. That's it. That's why. That's one application. So that's why sets are actually very useful. I've actually personally used them, set intersections and those things. We will discover them later. So the next step is if-else statements, conditionals. So let's actually check how if-else works. So this is the syntax. So you say if, and then you put some condition over here, and then you put some body, else another body. So this means whenever some condition is true, this part of the code is executed. If the condition is false, this part of the code is executed. That's how if-else statements work. So if this, do this, otherwise do this. That's how it works. So let's actually look at that thing. So this is a variable that I've assigned, and I've given the value of 15,000. So if the value is actually greater than 10,000, I am doing this one. So I am actually in Python, print is actually used to print the statements, print something to the console. So this is a function in Python. One important thing to remember is you can't learn the whole language immediately. This is how you actually discover new things. And now you know that actually how to print statements. So you keep doing these things and then you will know them by practice. So since this condition is actually true, it's 15,000, and I actually said its midichlorian is greater than 10,000. I'm going to print this line. If I change this value to 9,000, it's going to print the other one. You can try that out right now. So if you see, I actually printed it here. So why is this printed? Because the value is 15,000. What happened was, since the value is 15,000 and this condition is true, it went inside, executed whatever is there here, and then avoided everything else, because that's how if else works. It just prints this one, goes inside, executes. Even if there are 100 lines of code, it executes that and then doesn't even bother about this one. So there is something else. There is something else called elif. So let's say this is one condition. What if I have one more condition? So I can say elif. So this is short form for else if. So elif, I'm going to say less than, okay, equal to 0. Now this means this is another different condition. So there's one condition called greater than 10,000, another condition called less than, and then I can print something here. So if I set that as 0 and I run this, it's going to print nothing. See, that's what I printed here. That's how if, else, if, and else works. Next one is for loops. So I hope there are no questions here. So yeah, Jerry, so remove doesn't remove any value. It doesn't, it just, oh, you're explaining it, okay. Okay. Okay, for I in range of 10. So how does for loop work? So first of all, what is a loop? A loop is nothing but a piece of code that you use to actually keep running statements again and again. Let's say you want to repeat a single line multiple times. You can't keep writing that 100 times. You just put them inside a loop. So the syntax of for loop is, so there are two kinds of loops. There's a for loop and there's a while loop. We are going to start with a for loop. So this is how it works. I want to print the numbers 1 to 10 without actually saying print 1, print 2, print 3, and so on. So this is what I'm going to do. I'm going to say for I in range. So this is the syntax. So you just say for some whatever variable name. This is your choice. I is the most common practice that many people follow, but it's not a strict practice. You can name it anything you want. Just name it variable. It's just out of habit I'm saying I, but for just put a variable name in, and then now here you need to actually specify the condition. You need to specify what you are looping over. Like in this case, I want to print 10 times. So what I'm going to say is I'm going to use a function called range. So let's actually check what range does. So range is nothing but range. So I'm going to write it here. Range of 10 is actually equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 9. This is range. So this is what range will give me, 0. So range is nothing but 0, 1, 2, 3 until 9. So because I said 10, this is how Python works. Because I said 10, it's going to print 10 values starting from 0 and ending at this point. So that's why you see this here. So if you run this code, you're going to see what's happening is, okay, I'm just going to zoom out for 1 second. So what happened here is, it started here. This is the place where it's starting. It said for I in range of 10. So range means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to go inside print number colon I. Now I is initially 0, so it printed 0. Once it hits the end, there's nothing else here. This is some this is the end of the loop. So whatever you put in this space inside is part of the loop. So Python always uses 4 spaces. So you just, whenever you hit enter, you're going to see there's a small indentation. That is how Python works. In other programming languages, you might have to put those floor brackets, but in Python, it's just this small indentation, this small gap. This means whatever I put inside this indentation is inside the loop. Everything else outside is outside the loop. So I'm going to start at 0. I'm going to print number 0. Then it's going to go back, and then range has shifted to 1. I'm going to go inside, print 1, and then I'm going to go back. It's going to print 2. I'm going to go inside number 2, and then I'm going to go back. It will keep going until it hits 9. Once it hits 9, the condition is false. The range is done. It will just exit out of the loop. Exit out of the loop. By that I mean it stops here. This is how a for loop works. Can anyone describe the application of this for loop? Why do I even need this? Like, it's actually list. Like, it's helpful in creating a list. Like, imagine that I have to create a list of 10,000 numbers. I can't keep typing, right, manually. So I can use a loop over here. Iteration through a list. Yes, exactly. So you can try that. So you already have created a list, right? So you can say for I in, just put the name of the list. So you can just say mixed, and then just say print I. What's going to happen is, when I say for I in mixed list of items, every item from this is going to get picked. It's going to get dumped in I, and then it's going to go inside and get printed. Let's actually run that. So you see this, hello 1, 3.14, S, and world. They are printed because this is saying for every item in the list, print it. That's what's happening. So that's how a for loop works. There are any questions? Okay. So next, exactly, for automated operations with lists and all those things. So now the next one is, what's the next one? Yeah. So this is a much more faster method. It's the same for loop, but this is called list comprehension. It's just in one line. It's the same exact thing. If you see here, I've actually done the same thing, except the print statement for I in range 10. This is exactly the same. So when I put the whole thing in one line, like when I surround it with the list notation, and then I put I for I in range of 10, this means I am collecting all the I that's actually there in the range. This is actually much faster. I measured the time. You can, if you want, you can actually put, I mean, you can't use a stopwatch, but there are certain libraries in Python that allow you to measure the time. If you actually measure the time, there is a few difference of seconds between this one, and this is faster. List comprehension is a shortcut way of writing for loops. So you just do all sorts of computations here. So if you see this line actually prints all the 10 numbers. What if I want to square them? To square numbers, you just put 2 stars. So you said star and 2. This means I'm printing the square of every number. So 0, 1, 4, 9, 16, 25, and so on. So that's a list comprehension. It's just a shortcut way of writing, more alternative way of writing for loop, and it's faster. If you don't want to take me for my word, you can actually measure the time and see the difference for yourself. We can do that later. The last one is while loop. So this is another way of writing a loop. There is a difference. There are certain places where you need to use while loop. There are certain places where you need to use a for loop. There is a difference. I will talk about that. But essentially, a while loop looks like this. So it looks like as if the for loop has been broken up and expanded. So what I did here is, to actually run a while loop, the operation is the same. It's still used to repeat stuff. So while I is greater than 0, so I'm saying I assign I the value of 5. So as long as, so this is English, as long as I is greater than 0, print that. Whenever I is less than 0, just come out of the loop. That's all these 3 lines are saying. So as long as I is greater than 0. So the value of I, let me actually comment this whole thing so that you can see it clearly. Okay, so these things are called comments. So if you see this small hashtag, it's this is actually for commenting. So comments means you don't need to comment means you actually don't need to the code won't run. So comment is actually used to comment. So this is how comments are used. So I'm going to say this is a for loop, so that someone else who comes into the code will understand what I'm doing. That's how a comments work. So let me run this. thing. So if you see this, what's happening here is while I greater than 0, initially the value of I is currently 5. Then I did I minus equals 1. This means, this step means subtract 1 from I. So this is a shortcut notation. This is essentially equal to this. So what I'm saying is, initially I was 5. Now replace I with 5 minus 1, which is 4. So then it goes up, it checks 4 is greater than 0. Yes, it is greater than 0. It goes in, the value is currently 4. It goes down, 4 changes to 3. It goes up, 3 is greater than 0. Yes, that is true. You go inside, then the value is currently 3. Keep repeating that. When it hits 1, 1 is actually going to become 1 minus 1, which is 0. Now when it goes on top, it's going to see that 0 greater than 0 is false. Then it's going to step out of the loop, and that's why you don't see anything else. So that's how a while loop works. Now, I'm sure someone is just about to type, when do I have to use for loop and when do I have to use while loop? So I'll tell you the reason. So you use a while loop when you don't know when to end. You use a for loop when you actually know when to end. So here, basically, I exactly know that I know exactly that I have to run it 10 times. That's when I'll use a for loop. While loop, I could, okay, this might crash the notebook. Please don't do this. But if you say while true, this means as long, I don't even know when I'm going to end. That's when you use a while loop. So if you say this, let me do this. I don't know what's going to happen to the notebook, but okay, this is never going to stop. Actually, this is never ever going to stop. This is called an infinite loop. This is what crashes programs. Never do this, but essentially this is when you use a while loop. So you just hit stop. While loop is used when you actually don't know the condition, when you don't know when to end. Something is going to happen inside the loop. That's when I'm going to end. If this is the case, use while loop. If you actually exactly know when you're going to end, then use a for loop. That's a simple, clear-cut explanation. So I have loops and if statements are clear, I'll move on to the next step, which is functions. Are there any questions? Okay, so let's move on to functions. So this is what I described in the slides. Function is nothing but a piece of code that you actually have a name and you want to actually print, you want to actually run that piece of code multiple times. So let's say I want to print the squares of few numbers. What I'm going to do is I'm going to define a function called print squares. So the way that functions work, the way that you define functions is by saying def. So you just need to say def, put a space, and then this can be anything. You can name it whatever you want. However, there are certain rules in how you name these variables. So I'm going to show you what the rule is. So this is a valid variable name. This is fine, but this is not valid. You can't do this because it's starting with a number. So there are certain rules where you need to follow when you define variable names. It can start with an underscore, but it can never start with a number. It's common in most programming languages. So that's why this is a good practice in writing function names. I think this is called camel casing, or I'm not sure, or snake case. There are multiple different ways of writing these function names. So print squares. This clearly tells me that this function is going to print the squares. So whenever you write functions, you will, if you explore scikit-learn or any other documentation, you will see some explanation in between. That's actually known as a doc string. So that's what I've written here. This is actually called a doc string. Doc strings are important because by reading the doc string, you will understand what the function is actually doing. So that's why doc strings are important, so that when someone else comes and looks at your code, they will know what's going on. So now you see that this function prints the squares of the numbers until the specified input x. Now you know what the function is doing. So forget about this. Let's discuss that later. But for now, try to understand the concept behind functions. Now let's save this. Every time I want to print the squares, I only need to do this. I only need to call the function name. I don't need to keep going inside and changing this to, like, I don't need to change anything here. I can use this, let's say I want to use this line of code somewhere else, in some other file somewhere else. I don't want to keep copying and pasting the whole thing. And there is a reason, because if there is an error somewhere in this line, imagine you copied the same 4 lines 100 times. You have to go in those 100 files and change every thing. That's so time taking. Function allows you to cut through all that. You just define one single block of code, run it multiple times. If there's an issue, you go back to the same function. You don't need to keep going in those 100 different files. Yeah, it is a snake case. Yes. Okay. Good point. So how do you know the data type of the return value of the function? So in this case, I am actually not returning anything. So if you notice, there is no return statement over here. That if I write a return statement, it just depends on this one. So if I get, this is unnecessary. Why did I do that? Let me. Okay. If you remember this is how you determine the data type. So these are the different data types. You have integers, you have strings, you have characters, you have floats, you have strings. You need to know which one you're returning, and then you will automatically know. The other way is, yeah. So that's basically, okay, let's say right now here I'm going to say return x. I'm actually returning an integer. I'm just returning that value. So you see that the value is actually here, like what is that? This value, the 10, the value that's actually returned here. If I say return x, so you can do this. What you can do is, the way you find out the type of something is by actually saying type. So you need to say type. So just say type, and then you say 10. So it's going to say int. So you can just do the same. You can say type and then wrap it around that, and you say int. That's how you find the type of whatever is written. So you just you can just do this thing here. So after that, I think you can also do this. I'm not sure. I think this is right. So if I say, okay, no, it's a different thing. Sorry. Okay. So now let's. So did you all understand the concept of function? A function, like, why do you need to use function, and how do you actually call a function? So this is how you actually do it. You don't need to return anything here, because I'm just printing something. All I'm doing is taking in the number and then printing all the squares until that number is reached. So until the x value is like less than 100, like I keep printing that stuff. So until 10. That's what the function is doing. Okay, that's another good point. So why is the argument 4? So let's say I actually forgot to input something. That's the default argument. So that's why the argument is there. So that if I don't put that, I'll actually get an error. So it's going to say missing one required positional argument x. So to avoid these things, you can define a default one, let's say 5. That's actually going to show, let's say this is the first time I'm looking at this function. I don't even have any documentation. I want to know what it does. If they have defined default arguments, then you can just run it, and then you can see, okay, fine. Now I know that it's printing the squares of the numbers. That's why you need that. Okay, so what is the next one? Okay, so now that you understood functions, let's move on to something called Lambda. So this is very important, and it will be useful when you use Pandas. So Lambda is a shortcut way of writing the same exact thing. So you see that I've actually done so much to print the squares, and I'm doing the same thing here in just one line. So essentially, Lambda is actually a shortcut name for, it's a shortcut way of describing functions. And this is a syntax. So you have Lambda, and then you have a variable. This variable can be anything. It doesn't necessarily need to be X. It can be even A. So this one is actually equivalent to this. So this single lambda expression actually means this. The expanded version is something like this: squared number a. These two are the same thing. Like this, it's going to do the exact same thing. It's just that this looks much cleaner and it's much more readable. So instead of defining all these things, I've actually defined squared number equals lambda a square. So all it's doing is this argument here corresponds to this one, and then what am I returning? I can even do like a comma b, and then I can say a plus b. 25. So if you say 50, because what I did, I actually, so this one is again equivalent to saying AB plus B. These two are the exact same thing. That's you use lambda. Lambda is just a shortcut. You will know why you actually need lambda. Why do I need to learn so many different alternatives? You'll actually be using lambda so many times in pandas that you'll actually try to. So you need both. You need to use this one in certain places, and you need to use functions in certain places. So that's essentially lambda. It's called a lambda function. You can, yeah, okay. Yeah, this is how I pass more than one variable. Yes. So a comma b, and then you just do this thing, and then this is how I'm passing more than one variable. So I can even do one more. So,
Annie, I think Alex has a question about the previously data type. He's saying for your first example on data types, I saw Python didn't have characters. Aren't single characters treated as exactly the same as strings?
oh, yeah. So, okay, let's explain. This is a string for Python. Okay, so the idea of character and string actually comes from the previous programming languages, C++ and C and all this. They have actually a distinct data type actually called character and actually called string. In Python, everything is a string in Python. Like, so if I see here, so this is str means string, and this is also a string. Essentially, both are the string, but the idea of character is this. You put it in single quotes and you have just one single letter. That's a character. You put it in double quotes and you have a bunch of characters. That's a string. But Python doesn't make a difference. It's there. It has been coming from previous. It's an idea that's been coming from. It's a general programming idea. It's not something related to Python. It's the character is okay. Character is defined as something that has is defined within a single quotes, and then a string is defined within double quotes, a bunch of characters joined together. This is a generic programming concept. It's not something that's related to Python. I hope that answers the question. There is no such thing as cat, but there is something as str. Okay, hopefully that answered the question. Okay, so okay, this is important. What are some helpful shortcuts to know for Colab notebooks? So for Colab or any other notebooks, some of the shortcuts are okay. So if you want to comment out, this will just take 2 minutes. If you want to comment out the whole thing, you don't need to keep typing shift hashtag every time. Just select the whole thing. For me, for Mac, I do command question mark. I think for Windows, it is control question mark. So you just select the whole thing and hit control question mark or command question mark, and the whole thing is this one. And then the other one is the running the cell. Just hit shift enter. These are the only 2 shortcuts I know, and those are the only things I need to know. I don't need to know anything else. But there are tons of other shortcuts. Colab, it's there somewhere else in the documentation. But essentially, that's those 2 are good enough for now. So another shortcut. Okay, this is actually a very useful shortcut. It's there in Jupyter notebooks. I don't know what's the Colab thing. Okay, it's not there. It basically tells you okay, this one. So you just put your mouse over the function name and it tells you the entire doc string. It shows you what is inside the function. So it tells view the source code. Source code is nothing but right here. So that's some useful thing. So okay, let me finish this. Okay, so now time to deal with strings. So do you have any questions until this point? I've covered a lot. So if you dealt with Java, C++, or some of the older languages, you will see that there are so many data types: int, long int, double, float. There are so many data types. In Python, there's just few of them. So that's just how Python works. If you come from a C++.
Yeah, Annie. So I think we need to take a quick break,
Okay.
just in case like people need to take like a bio break or something. And also we probably need to speed up a little bit. So maybe after we come back.
After this, it's okay.
Yeah, just like quickly go through the string and the rest, and then focus on the pandas.
Okay.
And also we have a poll, Le Yuan set up a poll for the pace right now. So if you haven't feel that, please let us know. Right now, 70% of you guys think the pace is good. 30% think it's a little bit slow. So yeah. But so far, I think we should be able to cover all the content before 4 p.m. today.
So you can never have 100%. Either I'm going too fast or too slow. That's just how it is.
Yeah, that would be the ideal word.
No one can reach that. Like it's always something.
How about we come back and 3:20 or 5:20 if you're in Easter time?
Okay. Yeah, I guess that's fine. Yeah. Okay. Yeah, I forgot the arrow mark. Okay. Yeah, this is how you ensure the return type. I think Sunil asked this question. So this is how you actually ensure the return type. That's all. You just need to put the arrow mark. I put the colon. I'm going to put good always. Okay. Okay. After this, I am going to go quickly. I have you all have spoken, so obviously I will go quickly now. Okay, I'm going to share my screen. Okay, is everyone back? I think so. Can't ask that question anyway. Okay, so let's start. I'll be going a little bit quicker than I've been going till now. So as I've said, there's a question here already. Okay, so as I've said, strings are nothing but a bunch of characters. So this is how you define strings. You just put quotes and then just put strings within them. The reason that I'm actually focusing particularly on strings is because string manipulation is an important task. You'll be doing this quite a lot. So that's why you need to know certain tricks in dealing with strings. So I've deliberately kept this space over here, and there's a reason for that. I will tell it to you later. This is how you define a string, and then string slicing. Just like list, you can do string slicing. All you need to do is you need to put the same syntax as a list. So you need to put the starting index and then the ending index. Here, the indices are nothing but each character. This is where the difference between strings and characters becomes more important. So this is one character, this is one character, each one is a character, and each one has its own position. So if I say 0 to 10, okay, first of all, you need to run these. So this is the error that Mila got. So you do need to always, this is the same error that you got. So you need to always run this first so that Python actually knows there's a variable called mystr. That's what it says here. So now that you run this, it's going to print the first 10 characters. So if you actually count that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's what's been printed over here. So that's what happened. Now, how do I actually get the individual words within the string? So this is how you do it. You just say mystr.split. Now, when you say mystr.split, what happens is the entire string is actually split based on each individual words. If you don't specify anything here, that actually means that it is split based on the space. So this is the same thing. So if I actually don't specify anything here, it's going to use some default splitting. So if I mention space, that means it's going to split the entire string on the space. So that means if I say dot, where is the dot here? There's only one dot that's here. So it's going to split it on the dot. So it's going to select this dot and it's going to split this half and then the other half. That's what happens. If I don't specify anything, it's just going to be the default string. It's going to split based on an empty space, I think. So sorry, if I put a comma, okay, sorry. If I put a comma, there is no comma here. So obviously it can't split the string. So the default one is just going to split the words. If you want to split it on a specific string, let's say I want to split it at known. So I just paste known over here. So now this means that the cursor actually went until this point. It selected known and then it split the string into two halves based on known. That's what happened here. The known is gone and then as a string. So that's how split works. So now the next one is stripping. So there's a reason that I left the space over here. So in certain cases, whenever you enter some information in any survey or something, wherever there is a text, you accidentally leave additional spaces. When you are processing the text, you don't need those spaces. You need to remove them because they don't add any value to the text. That's where strip function works. So the strip function removes those spaces. So if you see this, I've said before and then after. So this is before strip. So the space is still there and this space is there. Now after strip, the space is gone and this space is also gone here. That's why you see this difference. That's where strip is used. So this is, I'll just repeat it once more. This is a string. This is where you index a string. You just index it like a list. Then you split the string using the strings, and then you just strip it. Last one is regular expression. Now, this is a bit complicated to understand, but it's actually a very, very powerful tool. Regular expression is nothing but a kind of a formula, or it's an expression that matches some pattern. So a regular expression is its own language, and you need to know that how to do it. So the best place to learn regular expressions is on W3 schools. So you can just Google Python regex W3 schools. The first link that you get, this is the best place to learn regular expressions. So this is how it looks. So regular expressions is nothing but a set of characters that are used to match a pattern. By pattern, I mean, let's say you have emails. Every email has @gmail.com, @facebook.com, whatever, your company name.com. Let's say you want to find out all the strings that have emails. It's a pattern, right? And what's the pattern? The pattern is there is an @ symbol, there's a string to the left, and there's a string to the right. That's where you use regular expression. Regular expression can match those patterns and then fetch you those strings. So I'm going to give you an example here. What I just said, you need to learn regular expressions. It's not very easy to pick up. It's not that intuitive, but still, if you refer to this chart, you will understand it. What I am telling here is, give me any capital letter or small letters, one or more of them, and then they're followed by 3 dots. Now in the string, where is that? It's here, right? String dot dot dot. So that's what I try to pull out. So I am saying, give me one or more. The plus symbol means one or more capital letters or small letters that are followed by 3 dots. And that's what I pulled out here. That's where regular expressions, and it's very useful in matching different patterns. So it's a good, powerful tool to explore, and I would suggest everyone at least give it a shot. And the next one is classes. So now, if you look at object-oriented programming, so let's object-oriented. So okay, this is actually a very huge concept. For now, I'll actually directly jump into Pandas data frames. I will get back to this in the end. This is actually a very big concept that will take some time for me to explain, but it's not that difficult. All it means is I have a bunch of functions that I've grouped together in something called class. That's all a class means. So class is nothing but a group of modules, and then each module has something called objects. So I will get back to classes, as that's, you don't need to know anything about classes right now, but you will get to know them later. But for now, a class is nothing but a group of modules bunched together, and it's a blueprint for creating objects. So I will get back to this later. So let's actually start learning some data science tools. I hope this pace is okay, so I'll keep going. So now, this is how you actually import other libraries and other tools inside Python. So this is actually how you actually get, if you want to use Pandas or Numpy, this is how you actually get them. So you say import Pandas. You don't need this for now. You say import Pandas. This means, what I am saying is, I have Pandas installed in my system. Pandas is a library. I have installed it in my system, and I'm importing it into my code. The reason is I want to use Pandas for certain operations, data manipulations or whatever. Instead of always typing Pandas, I'm giving it a shortcut. I'm just saying PD. That's it's just like SQL. It's just like the aliasing in SQL. So I'm just saying import Pandas, and I'm naming Pandas PD. So I don't, every time I want to refer to Pandas, I just say PD. I don't need to say Pandas. Because if you want to call something inside Pandas, you always need to type something like this. You need to say Pandas dot and then all the functions inside. Since I called it PD, I'm going to say PD dot. Okay, I have to run this. I'm going to say PD dot, and then basically all the, okay, they're not coming out now, but all the functions defined within this library are available to me to use, and I will show that in the next few cells. So let's actually start with NumPy arrays. So I've already told you that array is nothing but a data structure, which is a list of items grouped together. Now, someone asked me a question difference between arrays and matrices. This is the difference. So what happens here is, the way that I define an array is by saying np.array. This means what I'm actually doing is, I've said import NumPy, I'm calling NumPy, I'm aliasing NumPy, and I'm saying it's np. So from now onwards, I'm going to refer to NumPy as np, and then I'm going to say np.array. np.array means I'm saying I want to create an array out of this list. So the list is 1, 2, 3, 4, 5, and then np.array is the I'm converting this entire list into an array. The reason you might want to do this is, what's the difference between list and an array? It looks like the same, but you can actually do vectorized operations using array, which is not possible with list. You can do linear algebra, you can do matrix multiplications, you can square every element in the list in an array, and the operations are much more faster than when you do it with a list. And numpys and pandas are actually optimized for working on GPUs. I will talk about that later, but essentially numpy arrays allows you to do linear algebra, matrix multiplications, and all those other mathematical operations on top of them. That's what I've showed here. So let's run this cell. And if you say this, if you say to square every value within the array, you don't need to create a for loop and then loop through each element and then square each element. All you need to say is just my array square. And then what's going to happen is each value within that is squared. If you see 1, 4, 9, 16, 25. And then adding 10 to each value. You don't need to loop through them and keep adding 10 each time. You just add 10 once. This is actually called broadcasting. So if you Google this, Python numpy arrays broadcasting. Broadcasting means essentially what's happening here is it's 1, 2, 3, 4, 5, and I'm saying 10. The way what happens inside is 10 is actually broadcast into 10, 10, 10. This is what happens inside, and then that's why you get 11, 12, 13, 14, 15. This is called broadcasting. And after that, multiplying an array by itself. This is the same thing as squaring. So these are all the vectorized operations that you can do with arrays. I hope that's clear and there are no questions on arrays. So now moving on to matrices. So there is an operation in NumPy. You don't need to define a matrix like this. You can actually say np.matrix, but this is actually being deprecated soon. I don't know when, but the people who created NumPy are slowly going to remove np.matrix. So that's why I'm not going deep into this, but it is going to be deprecated soon. And you will see multiple things like this coming up. Something is being deprecated. These things are being removed. So just need to keep up with the disruption of this tech industry. So this is how you access matrices. So matrix is nothing but a 2D array. If you see here, just I'll zoom in a little bit. So if you see this, there are 2 square brackets here. So you put one outer square bracket and then you put 2 inner square brackets. So this means this is the first row, this is the second row. The first column, second column, third column. That's how it looks. So this is how it looks. So okay, let me print the whole thing and then slice later. So if you see, this is the first row, second row, column 1, column 2, column 3. That's the same thing that got printed here. It's a 2D array. Now, how do you select them? Let me select the first row. So the first row is again 0 indexing. So you say 0, and then you get 0. And then you get 1, you get the second row. What if I do 2? It's not there. So obviously that's an error. You can't index. It's called index out of bounds. So as you keep programming, you'll start recognizing these errors. You'll reach a point where when you know the error, you'll actually know what's going wrong. I actually know that index error means I'm actually accessing a wrong index. When you keep practicing these programming concepts, you will start, when you keep coding, you will start understanding these things. Now that we've printed the entire matrix, how do you slice inside? This is how you slice. So put a colon, and then before the colon, you specify everything you want to know about the row. After the colon, you specify everything you want to know about the column. So 0 to 2, that means I want first row, like, okay, this is the whole thing actually. 0 to 2. I want the first column, and I want the first column and the second column. So I'm going to do 1 to 3. Oh, sorry, you put a comma. My mistake. Sorry, you put a comma. So if you see this, I've selected both the rows, and then I've only selected the first column and the second column. By first column, always think about 0 indexing. This is the first column, like the column index number 1. So that's why 2, 5. So you got 2, 5, and then you got 3, 6. You got 3, 6. That means I'm selecting 1 and 2, column number 1 and column index 2, row index 0, row index 1. That's how you slice inside a matrix. Last thing is conditionals. So conditional is just if I these are array operations. If I want to get all the numbers that are greater than 2, I'm just going to say my array square bracket. Now what's my condition? I want to get all the numbers that are greater than 2. So I'm going to say my array greater than 2, and that's what I got. My array was actually 1, 2, 3, 4, 5, and I said my array greater than 2 means I'm only going to get those things that are greater than 2. You can always check. Sorry. You can always change these things, and you'll see that if I set greater than equal to 2, you'll get 2, 3, 4, 5. So that's all about arrays. And then these are some of the common NumPy operations. So NumPy has NumPy has so many functions like built into them. You can definitely check out the website. It's called numpy.org. So once you go over them, you will understand that this is used to generate random numbers. This is used to print between -10 to 10. And then you can do linear algebra operations using something called linalg. So the way you do those operations is by saying np. Remember, np is the alias for NumPy. So np.linalg. Linalg is the entire package that consists of algebraic operations built into them. Eigenvalues, covariance. You can calculate all those things very in a very quick manner using NumPy. Okay, so that's for that's what NumPy is used for. Are there any questions here? Yeah, yes. Actually, those are the operations that I was actually talking about. Matrix multiplication, matrix dot. You don't need to do them in linalg. NumPy itself has those operations. So you just need to say np.dot, and then you put the two matrices. See this? You just say np.dot, and you just get dot product of the arrays. You don't even need linalg is used for something like calculating eigenvalues, calculating covariance matrix. That's where linalg is useful. That answers your question. Okay. So NumPy itself has lots of matrix multiplication operations, and then later you can get other linear algebraic operations within the linalg package. So now we are getting into Pandas data frames. So it's not this Pandas we are talking about. So okay, now this is the point where I would ask everyone to actually make sure that you have these things. From now on, we are actually going to use train.csv. Just going to give 1 minute to see if someone has any issue, but otherwise, I'll start. Okay. So now let's actually get into Pandas data frame. So if you remember the slide, a data frame is nothing but your table, your entire CSV file. If you actually open that CSV file in an Excel, in Microsoft Excel or some other Excel tool, you would see that it has rows and it has columns. A Pandas data frame allows you to read that and then perform manipulations on top of it. Let me zoom back in. Okay, so a Pandas data frame is nothing but I wouldn't say it's a data structure, but it's a way to deal with your tables, tabular data. So if you remember, my alias for Pandas was actually PD. So I'm no longer going to say Pandas. I'm going to say PD dot and whatever I want to do. So whenever you want to call some function within Pandas, so Pandas is a library. It has multiple functions inside. So when you actually want to call some function inside Pandas, you always use this dot operator. So dot is used to call something inside Pandas library. So this read CSV is exactly like the previous function that we have defined. If you remember the print underscore squares, we have defined that function called print underscore squares. So in the same way, the creators of Pandas, they created a function called read CSV. This means I'm saying I'm pointing to the location of the train CSV file. Run that. Now df is the variable, is my variable that actually holds this train CSV file. It actually holds the entire data. How do I check that? How do I know what's in the data? Let's use another function that's called head. Head means I don't want to view the whole thing. I just want to get a quick glimpse of the data set. That's why you use head. Head means head is used to just, let's say you have 1,000,000 rows. If you try to print 1,000,000 rows, I'm sure your Jupyter notebook will crash or it'll just take a lot of time. So to quickly understand the columns and at least to get a glimpse of how the data looks like, I'm going to say head. When I say head, the default value is 5. So that's why I see the first 5. I can say 10 and I'm going to get 10. So that's how head works. Whatever I'm doing, try to do those things so that it's going to be a good practice. So when I say dot head means it's going to show me the first 5. Now let's look at the data. Now I'm seeing that there is something called passenger ID. There's something called survived. There's something called P class, name. And there are other columns. If you see, this is the same thing that I've described before. This is how you get a look at the data set before actually doing some manipulations. Now, another important thing, what is the size of my data set? How many data points are there? How do you get that? That's another function. So everything is functions. So now that I've actually defined my object over here, I'm just saying df.shape. This means that I want, let me actually show it to you separately. Copy this and paste it in another line, and then you'll see what it actually returns. So just paste this in another cell. Okay, I just want to ask if the speed is okay, because I feel I'm going quickly, but if this is fine, I'll continue like this. Okay. Okay. So just type df.shape, and then you will see that you will see what it's actually returning. It's actually returning the shape of the entire data set. It's actually telling me there are 891 rows, and then there are 12 columns. That's the shape of the data set, means that is the entire size. Now, what I actually did here is, this is a tuple. If you remember, I introduced the tuple data structure before. So the way you pull out the numbers from a tuple is in this way. So what's actually happening here is, if I say some variable, comma, some other variable equals df.shape, this means because there are two elements in this tuple, the first element is going to get extracted into row, and the second element is going to get extracted into column. That's how you pull out the elements from a tuple. You just say df.shape. You just say df.shape, and you need to see what df.shape is returning. So it's actually returning a tuple. So then I know that this tuple consists of 2 elements. So I know I have to create 2 variables to capture the values of the tuples, and then I'm using it to print them. That's this is a bit, you need to understand this part. So I hope this is clear. Okay. Okay, if there are no questions, even on Slido. Okay. Yeah, actually, that is my username. Yes, that's correct. Okay. So, okay. So the next one is the type. So now that I know the shape, the size of the data set, I've read my data set, I've seen my data set. What is the type of the data set? So what are the so by type, I mean the data type. So if I said .d types, so for everything you need to say df. So you need to first initially define your data frame object as df, and then you keep saying dot and then some other function. So when I say df.d types, that means it's going to tell me what is the data type. So passenger ID, let's look at passenger ID. Passenger ID is an integer. So that's why I got int64. What is survived? Survived is an integer. That's why I got this one. Name is a string. All the strings are usually called objects over here. Age. Okay, I've actually seen through the data set, there are some decimals inside the age. That's why it's saying float. And then fare. Fare is nothing but the amount, the cost of the ticket. So obviously tickets have cents and dollars in them. So that's why it's called float. This is the type of the data. Now, another very important aspect to know before you even do machine learning is to see how many values are missing. If you remember the slide, I've circled a small nan value. I think it's already here. Yeah, these values. So machine learning model cannot be trained without removing those values, or at least filling them up. Maybe there are certain machine learning algorithms that actually deal with missing values, but it's a good idea to actually remove them or replace them. Now, how do you decide whether you have to remove the missing values or replace missing values is something we will discuss next week, because that's getting into machine learning. But remember that you either have to replace them, remove them, or do something with them. They just can't be there. So this is a quick check. This is a good trick. Try to remember this. It will be useful for you anywhere. Just say always remember DF is this object. So when I say pd.read CSV, DF is the object that holds the entire data. Whatever I want to do, I will do it on top of DF. That's why I always keep saying DF. It's just a variable name. It can be anything. Now I'm going to say DF dot is null. So I'm going to check the number of null values, and then I'm going to sum them. Finally, what it's going to tell me is in age, there are 177 NaN values, and then cabin has 687 null values. Rest of them are fine. They're totally fine. There are no null values anywhere. So this is a quick trick to check the number of null values. DF dot is null, and then I'm summing. Another thing is columns. So DF dot columns. This means this will give me the name of the columns. So if you see, I just said DF dot columns, and it's going to give me passenger ID, survived, and all the column names. I hope everything is clear until now. If there are any questions. Okay. So now the next part is Pandas slicing. This is a very key point to understand, as this is what you will always this is something that you have to be able to do blindly, because from the next week you will keep using this again and again, and I can tell you that as you keep using this, you will get used to it. Pandas slicing is very useful because you will be able to extract rows and columns. You will be able to slice and dice your entire table using the slicing technique. So what is slicing? Let's say I only want to examine the age column. I just want to fetch this whole thing. I only want to fetch this single column here. All I need to do is take my data frame object, put square brackets, and then type the name. That's all. Just type the name. You can always try other columns as well. Just change it to survived, and you're going to get survived. Maybe change it to P class. You're going to get P class. So this is how you fetch the individual column names within the data frame. Okay, that's okay. That DF itself is a Pandas data frame. Let's actually check that. Someone asked me what is the type. So it's actually the data type actually is called data frame. So data frame is the data type. That's what's happening. Okay. So next one is okay. After this, next one is the other type of slicing. So what if, okay, this is getting me the individual column names, but what if I want to get the what if I want to get certain set of column names and then certain set of rows? That's where I use something called LOC. LOC means slicing using the name of the columns. So all I did here is, if you remember the matrix style of indexing, that's what is used here. This is sort of like a matrix, right? So you put a comma, and then on the left side you deal with the rows. On the right side you deal with the columns. Always remember that. That's always how it is. On the left side you have rows, and on the right side of the comma you have columns. So I am selecting 5, 6, 7, 8, 9, 10. Those are the rows, and then the columns, I said I want from passenger ID to name. So that's what this means. So I'm selecting passenger ID, colon, and name. There's another kind of slicing called ILOC. So this is fine. I have column names, but what if I don't know the column names? Then that's when I would use ILOC. ILOC is for indexing. So there's nothing about column names. All I'm going to do is get the row numbers, get the column numbers, and just print them. So this is called slicing Pandas data frame. You fetch the desired rows and desired columns within the whole data frame. So that's how you do it. One very key point to note in this, I don't know if you have observed this, if I said 5 to 10, I actually got the 10th one. But if I said 1 to 10, I didn't get the 10th one. That's another difference between ILOC and LOC. So that's a key thing to remember. The end one is actually shown here. The last number is not shown here. That's another thing to remember. Now comes the Lambda function. If you remember, I told you will be using Lambda again and again. So this is how you use Lambda. Imagine if you had to actually type diff type the whole function and then feed that function into this. This is much more cleaner to actually do it. The apply function, okay, try to pay attention here. This is a bit complicated to understand, but I'll try to explain it as simply as I can. The apply function basically takes whatever you have inside and applies it to each row. So in other words, forget apply for a second. Focus on this lambda. What is this lambda function doing? Lambda function is saying lambda x. So the variable is x. If the variable is f, lambda x. If the variable is female, change it to f. Otherwise, change it to m. That's what this lambda function is doing. For a second, forget about this apply. Just focus on the lambda. So the lambda function is nothing but I have declared a function saying that if the variable is x, if the variable x is female, change it to f. Otherwise, change it to m. Now, what is this variable? This variable is the sex. So this is exactly what apply function does. Apply function iterates through each row. It goes one by one. It goes through each and every row and it checks this variable. It is checking if it is female, then it is changing it to f. If it is male, it is changing it to m, the letter m, the character m. That's what's happening. So I've actually selected this variable and I've applied to every row this function. This alternative method is for loop. This is a far faster method than for loop. Apply actually, so Pandas basically is highly optimized for iterative operations. It's actually highly optimized. This is the alternative way. If you measure the time, this is far slower than the apply. So that's why it's preferred to get yourself comfortable with using apply instead of for loops. So that's the apply function. Does anyone have any questions? This is very key to understand because you'll be using apply a lot in the future. Okay. I hope you understood the use of apply. Now, this is some basic statistics. Pandas provides me a simple operation called describe. It's just the English word describe. What am I describing? I'm describing the data set. Yeah, what if you want to add a column with the calculated value? You can do that same. So okay, let's you just need to select the column name and then just say +10 and it will be added. Not for strings, only for integer types. So you can do that.
That means we want to increase another column.
Oh, add a column. Okay, sorry, I read it wrong. Okay. Yeah. So let's actually take this example. I'm going to create a new column in the same data frame that has this that has this one. So all you need to do is you say def, name it something else, category, and then just say equal to. That's it. It's done. Now, if you check df, you see there's a category. That's what happened. That's how you do it. Okay. So describe is nothing but describing the whole data set, statistics like these. Okay, these are the basic stats that you needed to know. So this is the count, the mean, the standard deviation, the minimum, the quartiles, the 25th quartile, the 50th quartile, the 75th quartile. This is the basic stats. Now, I will focus on this next week, but reading this table is so important. It will actually tell you so many things about the data set. You can actually see the numbers and tell what's going on within the data without looking at them. That's how descriptive statistics work. We will go over that next week because we will start focusing on these topics in the coming weeks. Now, this is the last part. I hope everything is clear until now. This is the last part. So the descriptive statistics will come later because this is not the right time to talk about it. As in machine learning models, when you actually get into exploratory data analysis, I will show you how to read this table. That's when it will become more clear. So there are, exploratory data analysis is something, it's called EDA. It means that it's just exploring the data. You just, before using some fancy machine learning algorithm, half of your business answers can actually come from data analysis. So let's say you're working at the company or you have a data set and your professor or your boss, they asked you, can you show me how many, like, can you tell me how many, like, what is the proportion of the male passengers versus female passengers, or how is the fare related to the gender? Is certain gender buying more? Is certain gender paying less for the fare? Those kinds of things are the questions that you don't need machine learning. You can actually get them through exploratory data analysis. The way that you do exploratory EDA is by using certain visualizations. These are two visualizations that are not the only visualizations, but some of the ones that it's very easy to understand for beginners. Seaborn is one package that has very good visualizations, and Matplotlib. These are the two libraries that actually help you visualize your data. So let's look at how to visualize them. So I'm going to assume that I'm not going to assume that you all know what is correlation, but I'm still going to explain it. Correlation is nothing but finding out the strength of the relation between two variables. Let me show it with an example. So if I take, okay, let's take this one. Let's take survive. Okay, if I take any two of the values, this tells me that survived is positively correlated with fare. That means, that is telling me that the strength, the way in which the two variables are correlated. That means that if one variable increases, does the other variable decrease or increase? It's something like that. We can't actually compare survived here, but if you take some other value like P class, okay, this is much better. This means that when I say P class is negatively correlated with fare, that means that those who are paying higher have a lower P class. If you check the data set, I think lower P class is actually wealthier people. Higher P class is the people who used, if you remember the movie, who used to sleep in the bottom bunk of the ship. So that's how you understand, that's how you interpret correlation. But this is not clear to me. I don't like to view numbers. So this is how you visualize the correlation between the variables. This is known as a heat map. So a heat, I'll zoom out a little bit. So a heat map actually tells me, okay, the default one, I think, okay, the type of correlation test, there are three: Kendall's correlation, Spearman ranked correlation, and Pearson correlation. The default one, I think it's, the default one is Pearson. Okay, you see here, the default one is Pearson, but there are other ones that you can choose on your own. So if I view the same correlation, same numbers as a heat map, it's much more interpretable. Now, what I can see is that the lighter color means positively correlated. Darker color means negatively correlated. So this actually tells me which variables are correlated. How do I use this information? This is used during feature engineering, which is the exact topic for week 2. Feature engineering, what it will tell me is, let's say you have a data set. You have height in centimeters and height in inches. These are the two features. Why do I need height in centimeters when I have height in inches? Or why do I need height in inches when I have height in centimeters? Those two are highly correlated. It's unnecessary for the machine learning algorithm to know both the different heights, which are essentially the same thing. That's how you remove one column and make sure, and the machine learning model actually performs better. You don't teach it unnecessary stuff. You actually teach it the useful stuff. So that's one way of using correlation heat maps. Now, this is the last slide of the day. We have exactly reached 5:59. So let's say I want to check how the fare feature is related to the how the fare feature is actually correlated with survived. I'm going to plot a histogram. So what I did, okay, it's not zooming out. Okay, what I did here is basically I just plotted a histogram of the fare versus the survived. That's all I did. I just plotted a histogram. Actually, it's not versus. Histogram is only plotted for fare. And then what I did is, Seaborn has something called as hue. So what it does, it plots the histogram and it colors the histogram according to the label of survived. So survived 0 means the person has died. Survived 1 means the person has actually survived the accident. So what happens is, when I say hue survived, that means the histogram is colored accordingly. So when I look at this, I can immediately see that the people who didn't survive are most likely not that wealthy. If you see the histogram, the most wealthiest ones are the ones that survived have a lower count and the fare is higher. Who pays a higher fare? The wealthier people pay a higher fare. The people who didn't survive, their count is much more shifted to the left. That actually tells me that the people who might not be that wealthy, and this is a hypothesis, this is not completely true, this is just my judgment. The people who might not be that wealthy are the ones who might not have survived. And if you see, the fare keeps going and then the orange color keeps increasing. This is how you can answer more than half business questions without even doing machine learning. I'm not discouraging you from learning machine learning. I'm saying exploratory data analysis is such an important step. Okay, that is week 1. I think I covered lots of topics. You will get your assignment soon. Sadly, I couldn't cover GitHub today, but I can make a video and share that video with you. And it's quite easy to pick up a GitHub. It's not that difficult. Okay, Leon.
Thanks, Annie, for the hard work. It's a lot of content to cover, and thanks to everybody who stays till the last minute. It's a long session, and appreciate all the effort that you make. So yeah, like Annie mentioned, we will share out more information later today or tomorrow. And also, if you have any questions, like say trouble getting into getting the data, or like any questions related with like the content today, feel free to post in the Slack channel, and we'll be as prompt as possible to answer those. So yeah, have a good the rest of the Sunday, everybody, and see you guys all next week.
Yeah, before we just get out, Annie, are you planning to send the assignments try virtually, and we do submit the assignments on GitHub?
So we will actually decide. We will send out the assignments soon after a few hours. We will decide what is the best way to send the assignments. But I still urge everyone to create your own GitHub accounts. Most likely it will be linked to that. But it's not just for assignments. GitHub is a very useful practice, and I would encourage everyone to just create an account on it. It's just like Facebook. That's it. So just create an account on that. I'll send you the details of the assignment.
Sounds great. So that's clear. And just for all the students to make sure to check the Slack channel for following up for the assignments. And thanks that, like Penny, I think you did a great job today, and thank you so much. And you see a lot of thank you on the chat. And yeah, hope everybody enjoying the first course, and let us know your feedback on the first week of course on the Slack channel, and feel free to send out questions you have during between now and next week. We will try our best to answer your questions.
Yeah.
Cool. Okay, have a great evening, everyone.
Thanks for the meeting.
Thanks, everyone.
Thank you.
Thank you very much. Yeah.